Hi students, today we continue with the problem solving based on criteria for similarity of triangles. Here we go for the problem. In figure, the figure is given. If triangle ABE is congruent to triangle ACD. Congruence means all the angles and all the sides are equal. Show that triangle AD is similar to triangle ABC. So first is given triangle ABE is congruent to triangle ACD. That means all the angles are equal. The corresponding angles are equal. That is angle A is equal to angle A and angle B is equal to angle C. Actually the B represent here the triangle is ABE, right? Here represent angle ABE. Angle ABE is equal to angle, here the C represent the triangle ACD, angle ACD, and the angle E is means here also three angles is there. We have to be very careful on which they are saying. Angle AEB. Angle AEB is equal to the same for the D, for this triangle, right? Because the triangle is ACD, this triangle. So this full angle. So angle ADC. So these are equal and the sides are equal. The sides like an AB will be equal to AC. That's the two thing. AB will be equal to AC. And next side is an BE is equal to CD. Next to the BE will be equal to CD. And the final is an AE is equal to AD. The AE is equal to AD. So this is what they given in the single sentence, the single word like a symbolic representation. These both are congruent, means these all are things are involved. We have to prove these two triangles are equal. So similar. So in triangle ADE and in triangle ABC, so we have to use the similarity criterion to prove that. We know that AAA, AA, SSS, SAS. So first let me look into the angle. So which triangle? ADE. So we are going to concentrate on ADE and ABC. ABC, right? So here you can see this both angles are same, right? Angle A is equal to angle A, since it is a common. Both triangle have the same vertices, same angle. So both will be the equal. If it is possible to one more angle is equal, then we can say it is similar, but it is not possible because this triangle we have an angle this, but we don't know what about angle this, and the full triangle also we don't know the full triangle. So only thing another possible is the sides. If we have proved a one side, then we can prove with the side involving that side involving the angles. So which angle we have proved? This. So we can use SAS. So this angle have involving this side AD and AB and AE and AC. So that we can choose from here given. We are talking about AD and AB. AB is there and AD is there, and AE and AC. AE and AC. So by using this we can prove that. So it is given AB is equal to AC, right? AB is equal to AC. If we bring this side, we can say it as an AB by AC is equal to 1, right? So next is AE is equal to AD. So if you bring to the left hand side, it will become AE by AD is equal to 1. So this is also 1 and this is also 1. So these two ratios are equal. So AB by AC is equal to AE by AD. And the angle including that side is also same. So by the two sides and one of the angle, by what criterion it is? By SAS similarity criterion, right? By SAS similarity criterion. So triangle ADE is similar to triangle. We have to be very careful on writing the corresponding sides. So angle A and angle A are equal. We already know that. Then we have to check with the D and E, right? Angle and angle equal. So D is corresponding to E. So D is in the first, A, B, C, right? That is what we have to prove. AD is similar to triangle ABC. So here we go for the next problem. E is a point on side AD produced of a parallelogram ABCD and BE intersects CD at F, and show that triangle AB is similar to triangle CFB. So first we have to draw the figure, then only we can prove it easily. So it is given a parallelogram ABCD. And it says E is point on side AD produced. So AD is produced and that produced have a point E. So E is a point on side the AD is produced. The AD is produced and E is on the point on the side AD, and BE intersects CD at F. So this is the E point, right? So BE is joined and that is intersecting the side CD at F. Show that ABE, so this ABE, this triangle is similar to triangle CFB. So this is easy. The first thing we can say, these two angles are equal since the vertically opposite angle, and another one is this angle and this angle are equal since the opposite angles in parallelograms are equal. So just by after drawing, just by seeing the figure itself, we can explain. So in triangle ABE and triangle CFB, so these two are vertically opposite angle, right? Parallelogram is equal, and the next thing is this two, right? CFB angle CFB and angle ABE, angle ABE is equal to angle CFB. This is by alternate angles are equal. So in the parallel lines, these are the parallel AB and DC are parallel since it is given as a parallelogram. So we can say by AA similarity criterion, right? So triangle ABE is similar to triangle the A is corresponding to the C and B is corresponding to F, and the rest is in this part is B. So these both are similar. So here we go for the next problem. CD and GH are respectively the bisector of angle ACB and angle EGF such that D and H lies on the side AB and FG of triangle ABC and triangle EFG. There is a two triangle then. The first one is an ABC and another is considered as an EFG. So the figure is very important. The figure representation is very important. So let me consider as an A, B, C, and this is a EFG. It said that CD and GH are respectively bisector of angle ACB and EGF. So CD is the bisector of angle ACB. So from C there is a one bisector angle. So bisector means the both angle will be equal. It cuts the both angle as an equal. And GH, from the GH is another angle bisector of an angle EGF. So this is G and this is H, and D lies on AB and H lies on FE of the both the triangle. If the triangle ABC is similar to triangle FGE, so triangle ABC is similar to triangle FEG. That means the angles are equal and the sides are in the proportion. So it is a given condition. We have to show that CD by GH is equal to AC by F. So don't go to the first to prove this. First we will prove the triangles are similar. So if we prove the similar, then it's easy to say that sides of the ratios are in the proportion, right? I think that CD, GH, AC and FG comes under this triangle. CD, GH and ACFG. ACFG. So if you prove this, then easily we can say that if it is similar, then they are in the ratios are equal. So let me first prove that the rest of the thing. So first I am going to prove the second one. So which two triangle we are comparing here? DCB in triangle DCB and triangle HGF. So I think by the angle we can prove, since it is given an angle bisector DCB and HGF, right? Here the angle B and sorry, there's a change in the question. It is an angle HGE. So here is an angle HGE. HGE, this triangle. So here we are going to compare an DCB and HGE, this triangle. So this is also bisector. This both angles will be equal. So by the given we can say that this angle B is equal to angle E, right? So this triangle contains an angle B which is equal to triangle angle E. This triangle contains an E. So these are in the equal, since it is given. And the next is given the bisector, right? So here it is given an angle C is equal to angle G. So this angle is equal to this is G, right? That is what given in the similar criterion. So by that, this the bisector will also be equal, right? The bisector of equal angles are equal, right? We know that it is given an ACB is equal to angle EG, sorry. So triangle ACB is equal to EGF. So this bisector will also be equal, right? So therefore triangle ACD and DCB will be equal to EGF and HGF, sorry, EGH and HGF, right? Triangle ACD will be equal to triangle DCB, which is also equal to EGH and is also equal to HGF, right? So from this we can say this angle and this angle are equal, right? So which this is including the angle like DCB. So angle DCB, here it is that, which is equal to angle EGH. So here we have proved one thing and here we have proved another angle in the triangle. So both are similar by AAA criterion. So by AA, so two angles we have proved, right? By AA similarity criterion, triangle DCB is similar to triangle. So we have to look on the order. We know that B and E are same, and here it is the C and G, and the rest D is E. So H, right? E is corresponding to B. So H and C is corresponding to G and B is corresponding to E. These both are similar. So next we are going to prove the triangle DCB is similar to HGF. Triangle DCA and triangle HGF, right? DCA and HGF. The same way we can prove. So DC and HGF, which two angles are given? It's already given there, right? You can see that angle here, this given corresponding. So angle A is equal to angle F. I hope that angle A and F are in this triangle A and F, right? It's there that angle A and F. Only one angle is there, right? So angle A is equal to angle F, which is given. Given means it's not directly given, it is given as a similarity. The next we can say by the bisectors are equal. So which two will be equal? So here we are considering a DCA, this triangle, and HGF. So already we proved one angle, this angle and this angle are equal. Then we can say this bisector and this bisector are equal. So this bisector is an ACD and this is a HGF. So angle ACD is equal to angle HGF. This we already proven here, right? ACD and HGF, which is a, you have to write the reason in the bracket. Bisector are equal, so therefore by AA similarity criterion, triangle DCA is similar to triangle A is corresponding to F, C is corresponding to G, the rest is H, right? So H, C is corresponding to G and A is corresponding to F. So both are similar, right? So then we can, actually this is the third one, then we can go for the first one. So we have proved this are the similar, right? So from third proof we get that DC by HG is equal to next to CA by FGF, CA by GF is equal to DA by HF. I hope this two is what we need to prove, right? Let's see. CD by GH, yes, here I represent as an DC, both are a GF. Yes, this, right, is equal to AC by FG. Here is that AC by FG. The order is changed, doesn't matter, right? So therefore CD by GH is equal to AC by FG. We have proved. So here we go for the next problem. Side AB and BC and median AD, side AB and BC and median AD of a triangle ABC are respectively proportional to the side PQ, QR and PM of a triangle PQR. Show that triangle ABC is similar to triangle PQR. So first the given is, what is given? There is a proportional. So AB, respectively I said AB by PQ is equal to BC by QR is equal to median AD by PM. It says a median. So AD by PM. It just given a word median. So median means what? It cuts this base into the two equal parts. So BD is equal to DC, or else we can say it as a half of a BC, right? The same here. QM is equal to MR. QM is equal to MR, or it's a half of a QR, right? That's what it says in the word median. So that is also we have to observe. Then we have to prove that triangle ABC is similar to triangle PQR. So here you can see that it's proved already triangle AB and BC, PQ and QR in the ratios. If we, instead of the side AD and PM, if we proved AC and PR are similar, or else if the angles, the side including angles, we have to prove the equal, then sure we can easily prove that the both are similar. So here we go for proof. There is no constructions here. We can prove by the given. So instead of an given here as a BC full thing, first I will prove this median. Here already gave AD by PM. Let me prove this. These two triangles are similar and the angle will be getting an equal. Then we can say that by SAS both the triangles are equal, right? So we know these two things are given, right? So instead of BC we can substitute a BD or DC, right? BD or DC. Let me take this, because this angle only we have to prove an equal, right? So let me take this BD. So half of BC is equal to BD, then BC is equal to 2 times BD. The same for QR. This angle we are going to prove the QM I will take. So QM is equal to half of QR, then QR is equal to 2QM. So instead of BC and QR I am going to replace with that AB by PQ is equal to 2 times BD. Instead of BC I am writing a 2 times BD. same by QR I'm writing 2 times QM is equal to AD by PM. So this is what given, right? From the given I have changed the 2 cancels, then AB by PQ is equal to BD by QM is equal to AD by PM. So this AB by PQ is equal to BD by QM is equal to AD by PQ. So these two triangles are similar now by triple S criterion, right? So 3 sides are there. So by triple S similarity criterion, so triangle ABD is similar to triangle PQM, right? PQM. So from this I can say these both angles are equal, and already we know that AB by PQ is equal to BC by QM, right? So now we are comparing the triangle, the full triangle ABC and the triangle PQR. So now I can say that angle B is equal to angle Q, since triangle ABD is similar to triangle PQM, which we already proved here, right? So we already proved. So then from the given we know that AB by PQ is equal to BC by QR. AB by PQ is equal to BC by QR, right? This is what given. You can see this angle is included in this side. So AB by PQ is equal to BC by QR, and angle B is equal to angle Q. This angle is included there. Then by SAS similarity criterion, triangle ABC is similar to triangle PQR. So here we go for the next problem. D is a point on side BC of a triangle ABC such that angle ACD is equal to BAC. So it is given the triangle ABC. And D is a point on side BC. I'm taking a pointer here, such that angle ADC. So this angle. So let me connect here to form an angle. So this angle is equal to triangle BAC, this full angle. So that CS square is equal to CB into CD. This is equal. Just by proving this, both the triangles are similar, we will be getting an ratios. With that ratio we can derive this. So you can see that CAR 2 CS are there. CS square means 2 CS square. So you have to choose the triangle which contains the side CA. Two triangles also should contain the side CA. The one is the big triangle ABC and another is a small triangle ADC, right? So in triangle ABC and the another small triangle is an ADC. So the first thing is given, this angle and this angle are equal. This angle belongs to big triangle and this angle belongs to a small triangle. So angle BAC, right? This is a BAC is equal to angle ADC, so which is given. And the next we can see this angle C is the common, right? So now we have proved that by AA criterion, right? By AA similarity criterion, so triangle ABC is similar to triangle C is corresponding to C and A is corresponding to D. So in A we will get a D, and for the C we will be getting a C, and here we will be getting a right? DAC. So from this we will get that sides are in the proportion. So AB by DA is equal to BC by AC is equal to AC and DC. So you can see that we need a CA square to CA. So here is the one CA and here is the one CA. Let me compare these two things. We will be getting this expressions. So comparing BC by AC is equal to AC by DC. Let me take BC here and BC here. So BC into DC is equal to AC into AC. So AC into AC we can write it as a AC square, right? So BC into DC is equal to AC square. That is what we need. AC square equal to BC into CD. AC is equal to BC into CD. Both are same. BC into DC or DC. Both are same. This is what we have to show. So here we go for the next problem. Side AB and AC and median AD of a triangle ABC. There is a triangle ABC. ABC, it is given, right? AB, AC and median AD. There is a one median AD and respectively proportional to the side PQ, PR and median PM of the another triangle PQR. There is another triangle PQR. It also contains a median. It is like the problem that we have seen already. PQR, right? And the median is a PM. Our proportion then show that ABC is similar to PQR. So two things. So previously it is given this angle, this side and this side are proportion. Here it is given AB, AC and BD, this side. So we have to prove these angles are equal, right? So what is given? Given AB by PQ is equal to AC by PR is equal to AD by PM. So this is what given. So we can prove this by the midpoint theorem. Previously we have proved by that here is the midpoint, we have took this side. But we have to prove this. Already they given this sides are the proportion, but in this side there is a no midpoints, the median. So let me draw from this point a parallel line. So this is a midpoint, right? And if we line a parallel line to the base AC, this point also we will be getting as a midpoint. The same from here I am going to draw a parallel to PR and this point we will getting as a midpoint from the side PQ that we have learnt in the 9th standard as a midpoint theorem and converse of midpoint theorem, right? So we are going to use this. So first we have drawn, this is a construction, draw DE is parallel to AC and MS is parallel to PR. This is what construction. So we are construction there because since we doesn't have a midpoint there, we are creating there. So by drawing a parallel by the converse of midpoint theorem, we have drawn the parallel and this one point is a midpoint and E should be the midpoint of that, right? So E is midpoint of AB, right? So that means, and one more thing, D is half of the AC. DE is equal to half of the AC. The same for here, SM is half of the PR. This we have learned in the 9th standard. You have to recall it. So from 1 now we are going to substitute that in this cases and we are going to derive the answer for us. So from, let me get it as a 1. So in AB, so AB can be written as a 2 times AE, right? Since it is the midpoint, and PQ also written as a 2 times PS, midpoint, right? 2 AE by 2 PS is equal to the same for that AC and PR. Here written AC is equal to 2DE by 2 SM is equal to AD. The AD by PM will be the same, right? 2 will be cancelled. AE by PS is equal to DE by SM is equal to AD by PM. Which sides of the triangle is this? AE, PS, DE, SM and the AD and PM. So these triangles are similar, right? So we can say these two angles are equal. So triangle ADE is similar to triangle ADE is similar to triangle PMS. Triangle PMS. So let me say this angle as a 1 and this as a 2. So now from this we can say that angle 1 is equal to angle 2, right? So similarly we can say, we can draw here and we can prove that. Let me consider as a 3 and as a 4. Similarly we can prove that. So we no need to do the steps, just we can say that similarly angle 3 is equal to angle 4. So now we can see that angle 1 plus 3 is equal to 2 plus 4, right? So just considering this is angle 1 plus 3. So angle 1 plus angle 3 is equal to angle 1 is an angle 2. So angle 2 plus angle 3 is a angle 4, right? This says that the whole angle A is equal to angle D. So we have proved the angle and we already know that side included as given that AB by PQ and AC by PR are similar. So by SAS we can say that. So AB by PQ is equal to AC by PR, which is given. So by SAS similarity criterion, triangle ABC is similar to triangle QR. So here we go for the next problem. A vertical pole of length 6 meter casting a shadow 4 meter long on ground at the same time. So there is a one vertical pole casting a shade here. It's a 6 meter and so the shade is a 4 meter on the ground. So at the same time the tower is casting, there is a one more tower which is casting a shadow 28 meter. Find the height of the tower. We have to find this tower height. So this we can join as a triangle, and we know that the angle will be, this both angles will be equal since at the same time it casting a shadow and this angle will be the same, right? So let me give this as A, B, C and P, Q, R, and this is also right angle. So now we can say this both are the similar, right? Since this is angle made by the sun, at the same time the angles are equal and it's a right angle, right? The pole and the tower will be always a right angle. So by AA we can say this. So before that we have to define what is the ABC and what is the PQ, right? So let AB and PQ are vertical pole and PQ is a tower and CB and QR are cast a shadow, casting a shadow respectively, right? So we know how to prove this. This both angles are equal. Angle ACB is equal to angle PRQ, and we know that angle B is equal to angle Q, which is equal to 90 degree. This is the reason that angle made by sun, right? That will be at the same time. It is given the same time, that's why it is the equal angle. If at a different time, sure there will be changes. So by AA similarity criterion, so triangle ABC is similar to triangle PQR. Triangle PQR. So therefore the sides are in the ratios AB by PQ. Ratios are equal. PC by QR. The first and last AC by PR are equal. So which side we no need about any AC and PR. The rest of the things we know. So let me ignore this, and these two sides we know AB is given as a 6 and CB is a 4. This is what we have to find, and RQ is a 28. So AB is a 6 divided by PQ is what we have to find, is equal to BC is a 4 divided by QR is a 28. So let me take a PQ here, and this will become a reciprocal here. So 6 into 28 by 4 is equal to PQ, right? So we can simplify it for an table 2, 3, 14 into 3 so 42, right? 42 meter. So therefore at last you have to write it's a 42 meter. See, height of the tower is 42 meter. Thank you.